Hello everyone, my name is Allison Yohannan. I'm the project manager for Across the Street Engineering, and we're here to talk to you today about the Eastgate Development Project, specifically our progress that we've made so far in this semester. As a reminder, here are our project responsibilities. For transportation, we have led by Jolie Overstreet, steel structural, Isabella Palomaro, concrete structural, Chance Troxa, and myself for water resources. Here's a general overview of our project. Since the last time we spoke, we've had some changes considering the loss of a member and an addition of a member. So the main change for the footprint-wise is that we no longer have transportation improvements to the south. We just have the Chapel Drive extension, the pedestrian facilities that go along with it, and the parking lot. And then footprint-wise, there's no change for structural. Just note that we're now looking at concrete as well. So now I'll pass it off to Julie.
Hi, so I'll be covering the transportation aspect of the Eastgate development, and so as Allison kind of refreshed you guys, my job is to design a roadway link from Sturdy Road to Stillhavy Road that also has pedestrian facilities. And since there's going to be a new link, we've also been designing the intersections of Sturdy Road and Chapel Drive, as well as Stillhavy Road and Chapel Drive. And then I have also designed a new parking lot for the university building that is to be constructed. So to start, here is the design criteria that I have been using to design everything. And so all of this is to the City of Valparaiso standards with note of the lane width. The City of Valparaiso outlines 20 feet lanes, but we got an exemption from the city engineer to have 12 feet lanes, as there will not be a need for on-street parking in this section of the city. And so with that, we have the typical sections, and as you can see, there is a 1 foot travel lane in each direction, and those are 12 feet in width, and they have a 2% cross slope draining towards the ditches that are on either side of the road. Everything that's on the outside of the ditches drains back in towards them, and the multi-use path has a cross slope of 1.5% to meet the standards of the ADA. The cross-section of the typical section here is a typical HMA section, and that is per the City of Valparaiso standards as well. Here we have the Sturdy Road intersection. So we designed a signalized intersection with 35-foot radii on all corners. And so you can see here that there are turning lanes as needed appropriate, and all of the storage lengths, just deceleration lengths, and taper lengths were designed per IDM Chapter 43, and this provides a level of service B for the intersection. The Stillhavy Road intersection is an always stop, and this provides a level of service B as well, and all of the turn lengths that are here were also used in the IDM Chapter 43 to be designed. So from that, we have our alignment, and so along this alignment, there are 3 horizontal curves, and all of them have curve radii of 750 feet, which meets the standards of the City of Valparaiso. And these were added primarily for aesthetics, but also to keep the speeds down on the road. And then in terms of the vertical alignment, the lowest grade that we have on the road is 0.52%, and the steepest grade is 3.58%, which meets the minimum and maximum requirements from the city of 0.5% and 8% respectively. From here, so now we have the university parking lot. So this is a 140 space parking lot with 10 foot by 20 foot stalls, and it connects nicely to Chapel Drive through that little driveway there, and then along the entirety of the parking lot there is a sidewalk that will allow people to walk from their cars to the entrance of the building. Finally, here is the first phase of maintenance of traffic. So since we are impacting 2 intersections along this project, we decided to break up the maintenance of traffic into 2 different phases as to not have such a wide footprint on the City of Valparaiso at one time. So on this time, we would be building the Sturdy Road and Chapel Drive intersection, as well as the first half of the alignment, and traffic would be routed around along Stillhavy Road. And then once this portion of construction is complete, we would switch over to phase 2, in which Stillhavy Road and Chapel Drive's intersection would be constructed, as well as the second half of the alignment, and all traffic would be routed around on Sturdy Road. For the future work, I will be developing my construction cost estimate, working on the pedestrian curb ramps along the parking lot as well as the multi-use path, and then doing the construction details that are necessary for the project. And with that, I will pass it along to Bella, one of our structural engineers.
So I will be covering the steel portion of our structural project. Just to recap the scope of my project, I was tasked with designing an academic building that is about 30,000 square feet that will accommodate classrooms, offices, laboratories, a covered outdoor space, and a 240-person auditorium with a stage, as seen in the image. So the first step in order to construct the building was to determine a preliminary building layout, and as you can see on the figure, this kind of accommodates all of the different rooms in the scope. So as you can see, there is a large room for auditorium, there's hallway space, and there are varying office sizes as well as classroom sizes. In order to determine the building framework, which includes the beams and the columns and the girders, I placed columns at the appropriate spacing, which was mentioned in previous reports and previous presentations, and then kind of adjusted the columns so that they would not interfere with open classroom space as well as hallway space. And as seen in this framework, there are pretty standard bay sizes. There are varying lengths just depending on the sizes of the classrooms. However, all spacings are satisfactory. There are two regions in which there is an abnormal kind of spacing just because there are larger beams. However, we will take a closer look at those later in the presentation. In order to analyze this floor plan and framework to make sure that it's satisfactory for the building's design, I have considered several different loads. We considered floor live loads, however, since this is a single-story alternative, these occupancy loads were not necessary for the design of the framework. So then roof live loads and roof dead loads were considered for the design. Because we'll have an ordinary flat roof on the building, we will use a value of 20 PSF to load the entire building. However, we also have to consider the roofing materials, which will include the roof decking itself, which will be a metal decking. That was found, all the values were found with the Volcraft manual, which is one of the standard producers of these metal decks. And also, at this time, only insulation and waterproofing were also considered. They were selected because the waterproofing membrane is like a standard membrane that is typically used, and the insulation is fire resistant, which is more ideal for a classroom setting. So all of these dead loads were added as well as the live loads. And in addition to that, we also considered wind, seismic, and snow loads. However, for designing the gravity system, only snow loads were considered at this time. All of these values were taken from the ASCE 7 hazard tool and stated in the table. However, the flat roof snow load was calculated in order to test the framework. So once this was calculated, this actually was the controlling load on the building because it was larger than the 20 PSF. And also the velocity pressure is calculated at this time, but it will not be used until the design of the lateral system. So just to take a closer look at the framework, those two areas in which larger beams were used are shown in the figure. So this is because in the project we are requiring an auditorium and also hallways and offices. The way that the columns laid out, they would interfere with open floor space and also hallway space. So we removed the columns, and in doing so we were left with some longer beams. However, these beams were tested both in the horizontal and the vertical, and it was found that placing the long beams in the vertical was more satisfactory to withstand the loads that were loaded onto the building. And so in order to come up with satisfactory members for the framework that was proposed, a RISA floor analysis was performed by loading the framework with all of the loads as previously mentioned, and then hand calculations were done to kind of support these, to see if the members actually could support the loads. So in doing that, shear moment and deflection were calculated. So then these RISA floor values as well as the hand calculations were both compared to each other, but also to the values that can be found in the AICS construction manual. And then it was found that they were all satisfactory, which is how I have provided all of these member sizes that will be used within the building. As you can see, there is quite some variation. Although they are all satisfactory, we are aware that there is quite some variation, and if the client were to request less variation in them, a further analysis could be done to kind of minimize the variation. And then some future work that will be completed on the project is, now that the gravity system has been designed, we will take a look at the lateral system, which will include bracing, connections, the connections between beams and girders, as well as the connections between beams and columns. And then once those have been designed, we will then look at completing drawings for those. Those drawings will include typical sections on the same connections that were mentioned previously, as well as elevation drawings to show the height of the building, and as well as a framework plan that shows the specific members at each, the member sizes for each member. And then finally, a construction cost estimate will be performed. At the moment, there is one using the square foot estimator on RS means. However, that is inaccurate at the level that we are looking for. So we will be completing a line estimate that specifies all of the different labor types, as well as all of the different materials that will be used. And now I will pass it to Chance, the other structural lead.
Thank you. So as Bella mentioned, I'm Chance. I'm in charge of the structural concrete alternative. So just a general project scope, real similar to Bella's in that it's the same property. However, one main difference, well, there's two main differences. One is that mine is a 2-story facility, and 2, it has concrete instead of steel, with the addition of a restaurant. And again, same real estate. So what I've done so far, progress to date, mainly first thing was the floor plan. I located, I'll show in the future slide, the restaurant on the base level, just for easy customer access, because then they're not walking through offices to get to a restaurant, which would not be convenient whatsoever. Determine the loadings applied, similar to Bella, with there being a restaurant, with there being classrooms and offices, we need to determine the necessary loadings. And then determine the dimensions of both the walkway and second floor beams based on those loadings. So here's a couple of views of the floor plan. In the green, that is office and classroom loadings. The blue is corridor loadings, and then the red is the elevated walkway. So theoretically, I assume that offices and classrooms would be located on the exteriors of the buildings, just so then there's a hallway in the middle of them to get access. And then the walkway will connect the hallways to those. This is all the second floor. This is all elevated. And then design requirements. This is what the ACI code basically entails. This was the basis of what I put into RISA floor. So the minimum beam height reflects the beam length, which is shown in the bottom section. So you have to have a height with the length divided by 18.5 to get a basic parameter for that. And then the slab height is based on that beam height. You divide it by 24. And then the ratio of the beam height to beam width is shown in the cross section on the top right, can be determined using that. So that was the parameters I put into RISA. Loadings applied, similar to Bella's, except I added a restaurant, which for the second floor, it's not going to matter because I located the restaurant on the ground. And then just to play it safe, when designing the beams on the second floor, I went with all corridors. I know on my plan that I showed offices and corridors, but that's like my assumption as to where they would put the offices. So I just assumed it to be corridor to play it safe, so you have 80 PSF throughout. Except the walkway, which is 60 PSF because it's a narrow walkway, so it has to be used as a walkway. And then an additional 4 PSF load, that's flooring, that's throughout both the walkway and the building, because that's what it's assumed to be. So beam layout, all the beams are running vertically except the walkway beams in both buildings. They're 20 feet. The walkway beams are going to be significantly bigger just because there's more span to cross between the two buildings. A potential alternative to this would be put girders where the walkway is, but that's it's more expensive. And another alternative would be a column, but nobody wants a column in the middle of their walkway. So the easiest thing was just to go with a larger beam. And then some basic slab and beam sizes. The slab 16 feet spanning for both buildings, and then it's 20 foot for the walkway. Again, this means that the slab for the buildings is going to be smaller than the walkway because it's less span. Beams, similar situation. The beams are going to be longer for the walkway, again, larger span for the walkway. So then they'll also have a larger height because there's more span, so they have to support more. And then here's just a basic like beam schedule. The end goal here is that MU has to be less than the nominal strength. This means your building's not going to collapse. So this is why I chose the steel I did, just to ensure those requirements. Same scenario on the walkway, except as you can see, there's a much larger load needed to be supported on the walkway, and that's because of that 32-foot span. And then in the future, right now I'm in the process of designing the roof. It's going to be a little bit different than the walkway because there's 800 pounds less per foot as the roof load compared to the walkway load. So we'll be able to save money by designing smaller beams for the roof. Rebar and spacing, that I need to determine 4 set roof beams once I calculate those. And then right now I assume the columns were 16 by 16, but once I verify the roof loads and put that on, I have to recheck that. And then finally we'll complete CAD drawings and finalize the cost once we know the amount of rebar. And I will hand it off to Allison with Water Resources.
As a reminder, the project scope for the water resources portion is to handle water quality volume and flood control volume within the site watershed. It's also an owner preference to treat the runoff for cadmium, copper, and zinc. And of course, we're looking to comply with the local requirements and standards. Here's an overall schematic. It's a little bit cut off, sorry about that. And it's kind of a lot to look at, but I just wanted to note kind of the major changes that have happened since the last time we spoke. I now have the addition of 4 culverts across the Chapel Drive extension, and I also added grass buffer strips leading from the Chapel Drive extension into the infiltration trenches, as well as grass buffer strips coming off of the building and parking lot leading into the rain garden and sand filter. As well, for overflow cases, I have conveyance ditches leading from the rain garden and the sand filter, which are, here in turquoise and orange, leading into the detention basin right there. For overflow, and in case of overflow of the detention basin, I also have conveyance ditches leading across the way to Node Creek. As well, for overflow from the Chapel Drive extension and infiltration trenches, I have conveyance ditches leading to the wet pond, and in case of overflow of that, leading to Node Creek. My progress to date is that I have designed the rain garden, sand filter, infiltration trenches, and the grass buffer strips accompanying each of the aforementioned practices. Here are the design requirements and standards for the rain garden. I won't drudge on them, but I wanted to show you what I'm looking at in order to design this rain garden. You'll see on the left we have a plan view with the building, and then to the west of that, a grass buffer strip in which the runoff would go across 7 feet of the grass buffer strip for pre-treatment, leading into the rain garden, which is 20 by 75 feet. On the right, we have a typical cross-section. I'll just note kind of the major design elements. The first one being a vertical pipe jutting 6 inches out of the ground surface in case of max ponding, which then leads to purple piping underneath in case of overflow. And then we have 3 inches of shredded hardwood mulch at the top with bioretention plants on top as well, 4 feet of planting soil, and a 3-foot minimum to the groundwater. And in this location, groundwater is 8 feet below the ground surface, so it's pretty much perfect for the minimum that we needed to satisfy. Here are the design requirements and standards for the sand filter, which I used to design the sand filter seen here. From the parking lot, we have runoff running south to the grass buffer strip, just south across 7 feet, again for pre-treatment, leading to the sand filter, which is 75 by 15. Sorry, I couldn't read. And on the right, we have a vertical cross-section, which, similar to the rain garden, we have vertical pipe jutting 6 inches above the ground surface for max ponding, leading into 4-inch diameter schedule 40 PVC on the bottom. And leading to that, it's within 4.25 feet of clean sand and geotextile fabric on top in case of clogging of the sand filter. Here are the design requirements and standards that I used for the infiltration trenches. I will note that most of the standards came from the Indiana Design Manual because we have roadside ditches serving as infiltration trenches. So here we have the infiltration trenches running the entire way of the north and south of the Chapel Drive extension. If you look at the bottom, we have a cross-section which Jolie had shown before, but I just wanted to note or point out the infiltration trenches and grass buffer strips. So on the left is the north side of the Chapel Drive extension, and on the right is the south So we have the Chapel Drive extension, which on the north side will lead to the grass buffer strip for pretreatment, then leading into the infiltration trench, which has 3-to-1 side slopes and a 3-foot bottom. And then on the right, which is the south, it'll lead into the grass buffer strip, which then leads into the infiltration trench. And on the other side of that is the pedestrian facilities, which will also lead back into the same infiltration trench. My future work is to revisit this infiltration trench design because I'm curious if I over-designed it, if I need to have the infiltration trenches running the whole way of the Chapel Drive extension, both north and south. So I may look at turning some of it just to roadside ditches regularly, and then some of it being the infiltration trenches. As well, I need to design the 4 culverts, the wet pond, the detention basin, and the overflow conveyance ditches. And that concludes our presentation. Do you have any questions? Yes.
Transportation.
Yes.
Where along that roadway are the minimum and maximum slopes? And maybe I missed it, but what is the design speed?
Yes, sorry.
The design speed is 30, and that was shown in the design criteria. And then the maximum vertical slope of 3.58%, that is over here. Because going down to Note Creek, there's a pretty steep change in elevation, so we were trying to stay as close to the existing as possible. So that's where the 3.58% comes from. And then the 0.52% is around here in the alignment. Pretty early on, there's a section where it's a lot of 0.58% or 0.5% and some change back and forth. So it's pretty close to the minimum, but it's still above the 0.5%. So that section of 0.52, I believe, is about right here, though.
So does the roadways then go back up to get to Silhavy Road?
Yeah, it matches existing at Silhavy and Sturdy
Okay,
as
so
well.
you've got a crest and
Yeah.
sag and then another crest to get back up. Okay.
Yes. Does that answer your question?
Yes,
Okay.
thank you.
Professor Aldebay, your hand was up.
Well, since you are on this drawing in here, how much of this design you did manually compared to using, for example, InfraWorks or like 3D?
I used Civil 3D for a lot of it. I used Professor Grossman's tutorial on how to draw a plan and profile to figure out so that it would do a lot of the calculations, but I was the one that set the standards and then tweaked the grades so that it made sense and your car wasn't just being jolted back and forth as you drove along the alignment.
Thank you. Chance,
Yeah.
I did not hear anything about lateral loading compared to Bella. She mentioned that there will be that wind loading or controls over earthquake design.
That's definitely something I need to look at for the roof, because all that was gonna be on top, I can show you sorry. Alright. Since I've only mainly right now designed the second floor here, all these loads here are all second floor, so I didn't consider any of the roof loadings yet, because they're not part of the second floor, they'd be a factor on top of the roof. So when I'm designing the roof beams, which is part of my future work, then I'm gonna look into that, look into the wind loads and the things that'll be a direct loading on top of the roof, if that answers.
No, I'm looking for lateral loading, like sideways wind loading, compared to gravity loading in here. How are you gonna accommodate that?
I think mainly in the future I'll look at that, but especially more for the roof. I was looking at primarily loadings that would be on top of the second floor in order to finalize those beam sizes. Because an exterior loading like a rain load or a snow load or even a wind load is going to have more of an effect on the roof when it's higher. If that answers. Okay.
So I had two questions, one for Bella. When you mentioned reducing the variability of your beam sizes,
Oh, yeah,
So
sorry, I'm sorry.
does that, are you just gonna are you just make the smaller beams bigger to match, or do you have to go through a whole new analysis, or how would you plan on doing that?
Well, so as the way that it is, I know looking at all of the different beams and especially the interior girders look scary because there are so many. So in an ideal world, there would be more uniformity, but due to the fact that there was that building layout that was proposed, the column spacing is different, which is why there is so much variety in the beams. However, like, I don't really see it being an issue. It was more so, if you kind of look at, I wouldn't be altering the lengths, because the lengths that were put in place are based off of the columns, which are based off of like a good proposed building layout. So it would be more of like the thicknesses of them. So if we did want to be kind of conservative, some of the smaller thicknesses would maybe be increased. However, obviously that would be more costly. So it is kind of just balancing whether or not a client would want it to be slightly more costly, so there is less variety. I guess it would also have to do with like the contractor and who is building it. But all of these beams and girders would be satisfactory, and there really is no need to change it to reduce the variety. It would just be for preference.
For ease of construction? probably?
Yeah. That in a sense. So at this time, they aren't finalized, they're all preliminary, so there is that opportunity to change it. However, we would not be interfering with the beam lengths perchance, unless like the client decided that they wanted to do away with this proposed building layout, which was mainly just done for convenience to make sure that the building would be able to accommodate everything that was proposed in the scope. So there's that.
So basically you would increase the smaller sizes to match the bigger sizes, to reduce variability.
Like the thicknesses, not the lengths,
Okay,
but yeah.
right, right.
Yes,
right,
not the
yeah,
lengths, the
right,
thicknesses,
Right, just,
but yes.
yeah, okay, thanks. And then other questions for Allison.
Mhm.
So you showed on your sand filter the vertical riser.
Yeah.
So you have a 6-inch diameter vertical riser going into a 4-inch drain tile?
No. Wait, I went too far, sorry. There it is. The 6 inches, I was talking about how far it's jutting out.
Okay.
So it would match the.
So yeah, so what's the diameter of the vertical pipe then?
I would think it would match would be 4 inches.
Okay. Thanks.
Sorry if that was confusing the way I labeled it, yeah.
Well, no, I mean, no, it was, I guess, the diameter's not labeled, is it? But
4-inch diameter and
for the vertical
On
one,
the
though? The
bottom.
vertical one looks smaller than the horizontal one.
then, yeah, it's not to scale. Sorry.
Okay.
I should have written that, sorry.
Okay. Okay, thanks.
Follow-up question like to Professor Weiss's for Bella in there. Is there a limitation from the architect on the depth of the girders of the beams? Because I'm looking at your schedule and I see they are as deep as like 33 inches, some of them
Right.
in there. Is that a problem?
So I had originally designed my building with like an elevation of like 14 feet, because that's like satisfactory. However, like after kind of analyzing it, I realized that I wanted to actually increase it to 20 feet tall. It is like an academic building, and I mean, we're used to tall ceilings in Gellerson, so I figured that would be a good conservative change. So as far as like the beam widths and the depths of it, it should not be a concern because of the height of the building, but it's definitely something to consider. As it goes on, it does just get challenging because we have the auditorium and we have all of those offices, so there really isn't the opportunity to place columns in those spots. No matter where the auditorium is in the building layout, we're going to have to do something different, which is why I highlighted that. So there's going to be some larger beams and girders in those regions.
And again, a follow-up in here, how are you gonna make that decision about to go with uniform size, let's say beams versus the different sizes? I mean, what sort of economic analysis you're gonna be doing?
Well, at the moment, there really isn't an economic analysis because at the end of the day, I'm going to be proposing, I'm going to be showing the client the proposed cost, and I will be using those member sizes. If the client realizes that they have extra money that maybe they would like used on something like that, then that can be something considered. But at the moment, with the amount that like the cost has been evaluated, there doesn't seem to be an issue at the moment, or like extra money to do so. So that would be kind of a consideration that's maybe made like in the upcoming weeks to see if that's what the client feels like they'd like to do. I mean, with the design itself, it does satisfy all of the loads, so there really is no issue, like, there is no need to change the beams. It's really just client preference and what kind of money that they have, but at the moment, we don't have that decision made.
I can assume I'm the client, actually there is a difference, because if I go with uniform beams, for example, in
Yeah.
there, workability for construction and for like the shopping, all of that will cut on the cost, but there will be the additional weight cost
Right.
for the steel in here. And so typically that is, if I am the client, I will ask that question.
Okay.
What will be the delta dollars
Right.
going with uniform size compared to like if I will be paying the shop for working with different team sizes and the same with from the mid.
Yeah, so looking at the, because like I said, I'm using RS means like the line estimator to determine it. So at the moment, since it is still preliminary, I do have several options in there. So as like shown in RS means, there is that option where if you have less variety, if you have a larger like amount of tons of a certain member, it will cost less in the long run. So I do have all of those prepped, and future I will definitely make sure that I look into that for you so that I'm giving you a better answer on that. But ideally, if there was no cost, I'd love to make all of the beams and girders uniform. However, I will analyze that cost for you.
So just one question for Allison, kind of looking at the sand filter. So can you explain a little bit, so the water's coming off the grass buffer going through the sand filter,
Yeah.
and it's gonna be down maybe 4.5 feet or 5 feet. Where does it go from there? So where does it go from that pipe?
So from the pipe, I plan to feed it into the conveyance ditches in case of overflow. The sand filter can't handle that much runoff. It'll go into these conveyance ditches, which will then lead into the detention basin.
And will that be that gravity, like from 5 foot down, or will it be pumped?
I'm probably not gonna pump it. I'm probably gonna use slope to carry the runoff there.
Thanks.
Any other questions? Okay, thanks.